actually our OpenLegacy hub started. So the first challenge, as I mentioned, was around how to enable backend access to the backend system, typically in a SaaS environment. So to tackle that, we created the OpenLegacy CLI. It enabled us to do automation. The CLI was kind of responsible to connect to the backend system, test the backend artifacts, and so on. And we started basically kind of designing first of all, also the terminology of the product. So we defined a module to describe backend application, asset to describe the backend operation, project to describe kind of the upfront project, describing a microservice or a function typically, a contract to describe the API interface, and a method to describe the endpoint or various endpoints as part of the product. It's basically technology agnostic, so it's not coupled to specific Java terms or any REST API terms, because we wanted to be technology agnostic in that respect. So the step started basically with creating a new design time engine that actually generate metadata from legacy artifact, from COBOL or other source of metadata. Instead of our previous generator that used to generate code, or Java code. R&D started working with Kotlin, so we made a shift from Java to Kotlin, which is a language that runs on the Java virtual machine, and more other technologies like Vertex as event-driven framework instead of Spring, and so. Also, a key element was kind of the flow engine. Flow, historically the IDE used to generate code. Creating orchestration was done through code. So we created basically a flow language, which enables to define steps of orchestration and mapping between input, output, and legacy backend operations altogether. And the flow basically enabled us to get into a world of no code and low code to create APIs containing orchestration and so on. We started also working with a UX team, creating a powerful web UI for the studio of the hub and providing immediate value. And the challenge was always around kind of the source of truth. When we work with the Java environment, all the metadata persisted in Java classes, and now we're actually running in a SaaS environment. We needed to maintain metadata, and we also started moving away from full code generation, because once we generated the code, we got a duplicate of the source of truth, one in the repository, one in the code. So we eventually started packing the metadata that runs inside generated outcomes like Spring Boot, and eventually enabled to run the products with the ability to still maintain all the metadata only in the repository, basically. In order to enable runtime deployment, we also enabled to disconnect the metadata. So we started exporting metadata also inside the microservices. So we came up with the concept of OpenLegacy export, or called OPZ today. Another key element was, again, we are running a SaaS. The SaaS was focused on the design time experience, but also we started creating the runtime environment, soon to be production, also for running production workloads of client. Today it's focusing on test workloads to enable easy testing of the creation of the API. And altogether, it can enable a kind of a easy experience for our user. The last element was around also repeatable use cases. So we also came up with what we call the solution center, which enabled to store repeatable either backend APIs or front-end APIs, things like buying, open banking on the front, things like FlexCube and Temenos and so on the back. And also ramp up deployment environment. So as a SaaS platform, it definitely makes sense to client to deploy on AWS or on Azure or on Google Cloud, or also on OpenShift, which is very, very popular in a financial organization. So we kind of also enable the platform deployers to deploy to those environments. And that's kind of the scope of features that eventually the first part of the journey, basically, how we came up with the hub. Thank you.